Good day, everyone. This is Orekoya Olusegun, Physics Mathematics Fundamental on YouTube. Please, before we go into today's exercise, do not forget to like, share, subscribe, and click on notification button so that you can have more of my video. Today, we are taking a topic in mathematics, and that topic is under vector, and the subtopic is the position vector. So we are going to do an exercise. Now, what do we mean by position vector? It's talking about having, I mean, to locate points in respect to a fixed point. Let's say this point here is at the origin, it's a fixed point. We have variable point A and variable point B. To be able to locate the position of A and position of B, we have what is called position vector. And we should also have it at the back of our mind that each vector is oriented at certain angle with respect to x-axis. So this vector A, we can say, is at an angle theta to the x-axis, and vector B is at angle beta to the x-axis. So to be able to locate this vector, we take this for point A, we use the vector OA to locate the point A. To locate the point B, we use the vector OB. So vector OA, as you move along this line to A, that's the call is called position vector of point A. To locate the position of point B, we take this vector OB. So vector OB from here to here is the position vector of point B. Now, we can describe the location of this vector with respect to their coordinates. Let's say vector A along the x-axis from 0 to this place is x1, and vector B along the x-axis from 0 to this place is x2, and then vector A along the vertical axis, the position of vector A is y1. Vector B along the y-axis, the position of vector B along the vertical is y2. So in a nutshell, I can write my A as coordinate s1, y1, and my point B as coordinate x2, y2. The x are called abscissa, while the y are called ordinates. Abscissa and ordinate are called coordinates. Normally, general point is written with x before y. So this x is called abscissa, and this y is called ordinates. So the combination of abscissa and ordinates are called coordinates. Please take note of that. Okay, now I want to find the position vector. I mean, I've already described the position vector of points A and point B. Now let's consider the line joining A and B. Let's say I'm moving from point A to point B. What is the vector that describes the location of point B with respect to point A? Now, each position vector that are here are known as a fixed vector. They are known as fixed vector or position vector. Fixed vectors. Fixed vector in the sense that their tail are tied to the origin, because the bottom of the vector A is the tail and is at origin. The bottom of vector B is the tail as is also at origin. Because the tail of A, vector A, and the tail of the vector describing position B is at the origin, they are known as fixed vector or position vector. But the tail of vector AB, this AB, is not tied to the origin. The tail of this vector AB is at point A, and the edge of vector AB is at point B. So this particular vector AB is known as free vector. It's known as free vector. So a free vector is a vector whose tail is not located at the origin, while position vector is a vector whose tail is located at the origin. Now, if I want to describe vector AB, this is what I'm going to do. Vector AB, that means moving from A to B, is like moving AO, then OB. So vector AB now, moving from A to B, I will move against vector A. So the vector A become negative S1, Y1. Since I'm moving from A to O and O to B, I'm moving along the location of a vector of vector B. So it's positive. I write that plus x2, y2. So in a nutshell, vector AB, which is a free vector, can be described in this format. I want to write this one in column form. That's x2, y2. Take away this one in column form, x1, y1. So the final solution to this is x2 take away x1, x2 minus x1, and this one, the final solution is y2 take away y1. So in a nutshell, the vector AB, which is a free vector, has this particular component. So I can write this one in rectangular form. This is a column form. I can write it as a x2 minus s1 I plus y2 minus y1 j, where I and j are called unit vector perpendicular to each other. Vector I is a unit vector along the x-axis, that is I, and vector j is a vector along the direction of the y-axis. So this vector AB can be written in rectangular form. What I have here is called rectangular form, and what I have here is called column form, and what I have here is more or less coordinate form. Now, with this result that I have here, I can use it to solve this exercise. Now, this exercise says find the position vector of a point lying on the line joining the points whose vectors are I plus j minus k and I minus j plus k. Find the position vector of a point lying on the line joining the points whose vectors are I minus j. I